is Rainforest Connection. So when you think of Internet of Things, I think of examples like this project, which is taking Android phones, repurposing them, making them solar powered, and then putting them in trees. And what this does is with algorithms, you can detect the sound of chainsaws. And then you develop a volunteer response effort. And so essentially what you're doing is you're putting ears into the forest. And this is preventing illegal logging. And so one of the concerns that I'm very interested in is biodiversity conservation. And well, I have an aerospace degree, so when you have a hammer, everything looks like a nail. And when I care about biodiversity conservation, it turned out that I was very interested in underwater drones. And I talked to the folks from OpenRV, which have the least expensive DIY drone out there, which is less than $1,000. And the new version takes only 4 hours to build if you're experienced. So it's a really easy design and really affordable. And compared to all other ROVs, this is really tremendous. It costs $15,000 a day to take a team out with an ROV, let alone the cost of renting the actual machinery. So what would you do with drones? You take them underwater, you outfit them with sensors, and all of a sudden you're collecting a lot of environmental data. But what's going to keep people putting these back in the water? And this is where I got the idea of a VR, AR experience, where you can take an Oculus and you take a drone about this big, and with a virtual cockpit, you can feel like you're in a human-sized submersible. And with Leap Motion controllers, you can reach out, you can touch screens. And so what we're designing right now is a device. So you take an OpenRV, you outfit it with sensors, and as it's exploring the oceans, as you're exploring the oceans and learning about them, you're collecting a lot of information for scientists. And this is important because it's reducing the cost of conservation research. And as we know it, coral reefs are going to be gone in 20 or 30 years. And we have no idea whether or not we're going to be able to survive the loss of those ecosystems. 1% of the ocean floor, it's about 30% of the fish species.
Why is it that we're losing them?
Acidification, global warming, a lot of corals suffer from bleaching, and it weakens the coral and then they die. So corals are actually meant to die, but they're meant to die and they build these structures that other corals grow on top of. But if you damage that surface ecosystem, you lose the food and the nutrients for all the fish and all the animals that use it for shelter.
What happened with that and all the other times that there was global warming?
I can't go into that now. We know that that's happening and that we're losing them. And that's the point. The point is we're going to learn more about the oceans. Because right now you can't afford to put that number of scuba divers out in the water that frequently. So like Google Earth just did a 360 scan of the Great Barrier Reef. And considering the cost, maybe they can do that once every 10 years. And that's great because then you have documentation of the disappearance of the coral reefs. And this is trying to give us more real-time opportunity to respond to those variables. And there's really interesting research being done with corals, such that you can stimulate the growth, 15 years worth of growth in 1 year. And they do that by slicing the corals, and then corals are this very interesting organism we don't understand very well, but it's like an animal, and it'll grow like your skin will heal from a cut, and it'll grow really fast if you slice it. And so that's how you can stimulate growth. So what we're doing is it's great to have this VR high-tech experience. It's great to have OpenRVs, which are a low-cost system, and you could go and throw them into the water. And so what we're doing is we're bootstrapping a technology company. The costs are relatively low to build this system, but we're going to have a lot of software development, things like machine vision. Can you create waypoints of interesting objects, and then create waypoints and go back and measure with machine vision whether or not there's bleaching, or take images of species that you see and then catalog the number and the type of species and then map it into a Unity environment, right? So what we're going to do as a young company, I have a fiscally sponsored nonprofit, MakerCore. We're going to take professionals overseas and we're going to teach them maker skills. And so I've been dealing with this. How do we get people more interested in environmental issues, and how do we help people help the world? And maker tourism is one of the things I think is most interesting. You take very intelligent people, you teach them maker-related skills, so they have a software development job in San Francisco. You take them overseas, they build an OpenRV, they learn maker skills. As a result, because we're a fiscally sponsored nonprofit, there's a whole lot. We save them. It almost costs nothing for the attendee. The company gives us a high price per person to send them out there. And then people can donate their drones back. So if you live in a landlocked area, you can go build this drone, have the value of that experience, donate it back to us, it's tax deductible, And then what we generally do is we bootstrap fleets that can then man coral reefs or robots that can man a robot out in a coral reef. So, and that's really exciting for us. Our first trip is going to be in about 3 months. And we're working alongside nonprofits. So one of the cool things I just discovered is there are people actually doing photogrammetry underwater, which is 3D scanning coral reefs. And photogrammetry is extremely difficult. Light does not travel the same way underwater. So the first models, and I want to show you one of these, they're extremely small, but they're working to the point where they can do 10-meter square areas. And eventually, within a year or two, they want to do 100 square meters. And that's really great because you have the virtual environment. You can create these autonomous drones to travel through those areas to waypoints that humans discover, that humans decide are interesting. And all along, it's collecting information that are valuable to scientists. So here's an example of a 3D model of coral reef, and it's extremely high detail. Detail enough that you can recognize the species, if not by the structure, then also by the
That's amazing.
texture.
Can you get a volume calculation from that too? Will that spit out a number?
I don't know if it'll spit out a number directly because that's not what the software is designed to do, but this is Autodesk software, Autodesk recap software. They're working with 8 meters squared approximately. You could do a lot of things with that, right? You could drill down into the little details, measure the different types of species. I think for that to provide a lot of value, you want to get machine analysis and vision and algorithms. You don't want to do this by hand. So this is the nonprofit we support with our MakerCore trips, as well as our own VR, AR experience that we're building into the OpenROV. And this is a lot of fun. OpenROV is an open source company, and they're really designed to take on small teams like us who do R&D and then incorporate accessories into their product and then spread it out to their community. When I think about OpenROV, 1,000, 1,500 OpenROV sales seems relatively low for a market. But the most successful ROV companies will sell 200 units in a year, and OpenROV will sell 1,000.
I'm trying to understand that part. I think you've said it a couple of times, and I still don't get it.
Which part?
So you can teach people how to build this thing, and they build it, and they do it because they want to learn how to build it. And then do they want to do something with it? They want to do it for fun? Or
Yeah, if they want to take it home, people can take home the rover. If they want to donate it back to our project, what we do is the next phase of development, which is we add the sensors and we actually build in our stereoscopic vision system. And then down the road, they can then use our telepresence system to dive into that robot and see the reef that it's monitoring.
Right. Other than like doing it for a few hours or once in a while, what reasons would people have to want to do it? Like I could see where a company would want to like explore something that they needed to retrieve or do something.
Yeah, and this is where it becomes citizen scientry, right? Because we get images of Mars, and humans stitch together, hobbyists stitch together those images of Mars because humans are better at certain types of image recognition than machines are. And those are volunteers. And so right now we don't have many tools for people to be citizen scientists and to say that they're interested in a region of the Earth or an issue and get real-time data about it. So this is opening up the ability to grow that community of people who want to volunteer over the course of their life for a variety of causes, and we hook them up to technological resources to make that possible.
People might be interested in a radiation sensor in there as well.
A radiation sensor? Yeah, I mean, people are concerned about radiation
Traveling
everywhere. Yeah. That's very true. Yeah.
Do you have any, so for those that do have Rift, do you have any sample demo reels?
Yeah, we're working on it. I'll be able to show you. We're going to take another 6 months to do our first demo, but we do have integration with Oculus right now. You can move the gimbal with your own head motion. We don't think that's going to be valuable for the OpenROV case because we don't want to initiate any nausea, but for any entertainment application.
Other quick question I have is how do you know underwater communication? Like in the air, you usually
Yeah, so I just researched this. You put a lot of nodes in the water, and then you do audio, and you use vision. And audio is self-correcting, so you'll be off by 2.5 meters at most for large distances. And then because we already have a camera system, we can probably use visual and audio. We're also working in like highly detailed areas, so we're not in open water. I think it's going to be easier to get lost in open water.
How does the military keep track of where they are in big water? I know there's those super giant antennas that are on this that they can use for communication. How do they do their position? And also, my other question is, so you definitely have a camera. Is there any other standard sensor package that you want to include in all the drones?
Yeah, for these drones, we want to take into account temperature, pH, salinity, oxygen levels. So there are a lot of different sensors we want to integrate.
Got all those sensors on it.
Yeah. And then for us, like that user interface of how is it best to show the data? Do you show the data overlaid over a map, which is something that the MBARI is working on, so the Research Institute. The other thing is, like, do you show change over time? How do you show that? How do you show information about species? So we've got a lot from a user design and data visualization perspective. Yeah. More questions?
Where in the world do you want to record first? You're going to go there yourself.
Yeah, so we're starting in Hawaii, and it's kind of we're going to work with the Hydrus, which is located in Hawaii. My next location is Indonesia. Is watching it as a biodiversity hotspot is to go to Borneo. It's Indonesia and Borneo. Basically, there are 14 biodiversity hotspots. A lot of them are coral reefs, and we're going to aim at those. So why do we focus on biodiversity conservation? There are a lot of issues with environmental change. Biodiversity is one of my greatest concerns because you can't replicate the amount of time gone into evolution, the knowledge and information that are in each of those species. You also can't replicate stable ecosystems. So once they fail, they're really, what are we going to do, right? So they're about, you don't put as much effort into preserving. I don't. I know people pour tons of money into crops, right? But monoculture is one of the causes of biodiversity decline, and one of the reasons why we're going to have a lot of weather issues. It's really interesting, the reason why I picked Indonesia. There was research done on local climate change by doing really dense natural forests and putting cash crops in it. You could reduce the local temperature by 4 degrees Celsius and cause rain. So trees actually draw rain out of the air. And so there was this hope of local climate change. And that's why I'm very interested in biodiversity hotspots and this kind of restorative, working with the ecosystem. How do you change local pH? How do you change local temperature and local salinity? But first we need to know enough about it, and we just don't have the information.
Can I just ask, the chainsaws in the forest being driven by the microphones, I didn't hear all that you said. Was that something you guys were doing?
That's not something we're doing. That's a program that I supported. They're called Rainforest Connection, and they're just an example of these things are real and they're happening. That one does not give you, as an individual, the ability to watch a forest and see how it's doing, but it has the potential to do that, and that's sort of what I'm driving towards, is you personally can keep track of issues that are really dear to you. And the hope is that people develop an emotional connection to the coral reefs that they visit, and if they can witness the decline over the course of a few years, that they can also mobilize efforts to protect it. Because people are going to be a lot better at protecting specific resources than trying to protect the whole world, and by that hitting this, developing apathy or loss of sense of influence.
But even if people suddenly care, is there any way to reverse what's going to happen in the next 20 years?
We don't know, and the thing is, I think we can. And I'm saying that because I'm very hopeful and optimistic, but research like they're doing to prove that they can grow coral reefs 15 times faster, that's stuff you wouldn't uncover unless you put energy and time into it. And now that we're uncovering it, it's probably possible. And they're not just growing the coral reefs faster, what they're also doing, and I can't take credit for this, is that they're testing the coral reefs against the environments that they think they're going to grow in. and then taking the ones that survive. And so they're sort of accelerating the evolutionary process. Or they're sort of predicting what's going to be the byproduct. So which species would die off, and then they nurture the ones that survive.
I think if I make the drones nicely, well, we
We haven't built in the ability to manipulate your environment. The first thing we'll probably do, once we get our functional drones, is to build in this photogrammetry setup so that as you scan an environment, you get a 3D map of it. And so what we'd probably do is we'd go to our pilot site, do a 3D scan, and pay for that as a pilot project. Piping that into Unity is going to help us with controlling the drone. And then we're going to try to build an audience of people. And these real life visits are going to help drive an audience of people. There are a lot of people who are landlocked that will never scuba dive. And the hope is you can create this educational portal. You can pick up an Oculus, search through our drones, reserve one, and then you lead a classroom through a tour of a coral reef. And so that's growing the audience that right now has no connection to the ocean at all. And we're right by the sea, so we don't really appreciate that, but other people will. And it sounds like science fiction. I've been working on this project, and it sounds a little futuristic, but all the technology's there, and with the right specialists, it's actually moving quite fast. Yeah. Cool. Yeah. Thanks, guys.